Welcome to the project demonstration of lithium-ion battery charging using buck converter with fuzzy logic implementation. So here we are providing solar panels, non-renewable source output which is of 9 volts 5 watt solar panel. We are using that to charge our battery. So the battery ratings are 3.7 volts 2600 milliamps. While we charging this battery, in order to controlling the voltage regulation purpose, we are making use of this buck converter, and this converter will be controlled through the Arduino Uno board based on the fuzzy logic. There are two steps we are using: fuzzification and defuzzification. Initially we'll do the defuzzification and then after fuzzification. So coming to the defuzzification, the system will measure the voltage of the solar panel and then it start doing the defuzzification. And to check the output voltage, we need to get the output voltage of maximum 4.2 or 4.4 volts maximum. That is sufficient to charge our 3.7 volts. So for that we need to do the fuzzification process. Based on that, PWM signal will be given as input to the gate of this MOSFET. So coming to the buck converter, so there we are using the two capacitors at the source end and there is at the load end. Source and capacitor ratings is 1000 microfarad 25 volts. Load and capacitance is 100 microfarad 25 volts. And the inductor also. So inductor we are using 200 microhenry and the MOSFET is IRF 540. So here we connected the gate of this MOSFET to the 10th pin of our Arduino Uno board, and the output voltage, input voltage will be displayed on the 16:2 LCD screen which was connected at pin number 2 to pin number 7, and two INA 219 modules which are used to measure the voltage. This module is used basically for current and voltage measurement purpose. In our project we are making use of these modules for the voltage measurement from the source end and under the load end. In order to control the load end voltage below 4.4 volts, the system will regulate the pulse signal to this MOSFET by providing the duty cycle that is 70 to 80%. So when it is 70%, the voltage is 4 volts. When it is 80% of duty cycle, the voltage is going to be the 4.4 maximum. Whenever the voltage is more than the 4.4 volts from the main source of solar panel. Let us see the demonstration. So connect all the modules to the system and on the power supply to the adapter. Then initially welcome message will be displayed on the LCD screen, and then after init done means the both modules are connected properly. Right, as of now we are getting the more than a 4.8 volts. The system started the buck conversion to regulate that voltage, and when I am covering the solar panel, the voltage will be decreases slowly, and also the output also will be decreases. Here we have connected the output section of the buck converter to this INA 219, and input section was connected to this INA 1. So coming to the INA connection, there we can see the 6 connections. In that, 2 are plus minus power supply for this one 5 volts, and 2 are SDA SCL, those are the I2C pins. Another 2 are V in plus and V in minus. We need to connect this between the source and load in series. Means here the source is going to be the output of the buck converter. The output is connected in series with the battery with the INA 219. So now there is no buck operation is going because we are getting the less than our threshold voltage. Slowly increasing as we are using the defuzzification process. So it is slowly increasing the voltage, trying to hold that output voltage less than the 4.4 volts. Right, now it is locked over there only. So if you place this under full sunlight, will add maximum of 9 volts. Right, though the voltage was increases, the system locked that below 4.24 volts. Right, and coming to this LCD board, there we can see one potentiometer which is used to control the contrast of this LCD, and backside of this LCD driver we are going to convert the 8-bit mode because LCD consists of 16 pins. In that 8 pins are the data bits D0 to D7, but we are using the coding in 4-bit mode. For that purpose we are going to converting the 8-bit mode to 4-bit mode. We can see the remaining 4 pins are no connection. So in this 8 pins, these 8 pins consist of 2 are plus minus 5 volt ground, and remaining 6 are register enable and register selection and D0 to D7. So these are the main connections, and that register selection, register enable D0 to D7 D4 to D7 is connected to the Arduino Uno board at pin number 2 to pin number 7.